Today we're in 5.9 doing quadratic inequalities and then their graphs, because a lot of these ask for graphs, but regardless, graphing is going to be a necessary part of solving these properly. Okay, so let's get to it. So when you solve a quadratic equality, which is a quadratic equation, it's set equal to 0, and then you factor to get your zeros, your x values, okay? Here, your inequality is either going to be greater than, or equal to, or less than or equal to. So we are graphing or solving quadratic inequalities here. Okay, so the basic way that we are going to do this is to start by factoring, okay? My second sign there is a minus. So that means that one of these symbols or one of the signs is a plus and one is a minus. And I need two numbers that multiply to be this -2 and at the same time add to be a -1. Well, there's only two factors of 2, 1 and 2. So in order for the 1 to be negative right here, we have to have a -2 and a +1. So 1 times -2 is -2, and 1 plus -2 gives us our -1, okay? So we've got our factors now. Now we are going to set them equal to 0. So for just a minute, we are going to disregard the greater than symbol and solve for the x values. Now these x values are the zeros of the polynomial, but in our case right now, we are calling them the critical numbers, the critical values of x, okay? Now, we're going to put those on a number line. -1 is to the left of +2. And those are the only numbers you need on there. You do not need a full number line, okay? So from here, now this is where you need to pay attention. From here, we will separate this number line into sections, okay? We've got to the left of -1, in between -1 and 2, and then to the right of +2. Okay, so what we're going to do is we are going to pick a test number in each one of those intervals, okay? In other words, from -infinity to -1, -2 is a number that falls in that interval. You could pick -1.5. You could pick -1,000, -10, -8, -1,000,000. It doesn't matter as long as the number is less than, which is to the left of, -1. Now we're going to pick a test number in between -1 and 2. Well, obviously the wisest choice there would be 0. Okay, then for the last interval, we're going to pick a test number bigger than 2. So I'm going to pick a 3. Okay, now what we're going to do is we're going to plug each one of these test numbers in to those factors. Okay, and we're not looking for answers. We're looking for, is that answer positive or is that answer negative? So if I put a -2 in to x plus 1, -2 plus 1 is a negative number. If I put a -2 into x minus 2, -2 minus 2 is another negative number. Now, multiply those two negatives together and you get a positive. So that positive symbol is going to go into my interval. Okay, now, if I put a 0 in for x, if I put a 0 in for x, I have a positive and a negative. And positive times a negative gives me a negative in that interval between -1 and 2. Lastly, I will test a positive 3. So if I put a positive 3, I get a positive here and a positive here. Positive times positive is positive. Okay, so now I've got my interval table worked out. I'm going to go back to my original inequality symbol. I am looking for the x values, or the interval, I should say, where I have a positive, because I'm looking for the numbers greater than 0, which are positives. So that is this interval right here and this interval right here. So the way I state my solution is this way from -1 and this way from +2. Now let's talk about why those circles are open. Those circles are open because my inequality symbol is a greater than. If that symbol was a greater than or equal to, then the holes would be filled in. Okay? Let's do another one. Okay, so here's the next one. It says, solve that inequality and graph the solution set. So first of all, the idea is you get everything on one side of that inequality symbol with a 0 on the other side. That means the 5x is going to be added to the left and the 1 is going to be subtracted from the left. So our inequality becomes 2x squared plus 5x minus 3 is less than or equal to 0. Now that's what we are factoring to first find our critical numbers and then graph the solution set. So let's do a slide and divide on this. Because my leading coefficient is not a 1, I'm going to divide away the 2 and multiply it at the end. So for temporarily, I'm going to be factoring x squared plus 5x minus 6. Okay, so I need two numbers that multiply to be a -6 and add to be a +5. Well, one of those is going to be a plus and one is a minus because my second sign is a minus. Okay, so two numbers that multiply to be 6 and add to be 5 are +6 and -1. 6 minus 1 is 5, and 6 times -1 is -6. So we're good. Now we have to reintroduce the 2 that we divided away. Now, 6 divided by 2, the factor on the left, divides evenly. So 6 divided by 2 is 3. Now 1 divided by 2 does not divide evenly, so we're going to swing the 2 over and stick it to the front of the x. And there is what we have now for our factors, which are, in this case, our critical numbers. X plus 3 and 2x minus 1. Okay, so if that was x plus 3 equals 0, then x would equal -3. That is one critical number. If 2x minus 1, I'll do that down over here. If 2x minus 1 was equal to 0, we add 1 to both sides and divide by 2. X would equal +1/2. So they are the solutions, but in our case right now, they are the critical numbers that divide or create our intervals, our separations on our number line. And then from here, I pick test numbers. Anything smaller than a -3. So let's just pick a -4. In between negative 3 and 1/2, there's that wonderful 0. And greater than 1/2, number 1, okay? Again, they don't need to be those particular numbers. I could have picked a negative 12 to the left of negative 3. Anything less than negative 3 will give us the same solution as long as the number is less than negative 3, okay? Likewise for every separation, for every interval. All right, so now I'm going to put those test numbers one at a time into our, so I'm going to put them down here just so we have some more room. Okay, if we put a negative 4 in the first factor, we get a negative number. If we put a negative 4 into the second factor, we would get another negative number. 2 times negative 4 is negative 8 minus 1. Okay, so negative times a negative gives us a positive in that area or that interval of our table. Now we will put a 0 in. When we put a 0 in, 0 plus 3 is a positive, and 2 times 0 minus 1 is a negative. So we have a negative. Positive times a negative is a negative. And then finally, we will put a 1. So 1 plus 3 is a positive number, and 2 times 1 minus 1 is a positive number. So positive times positive is positive. Okay, now we got our table filled out, and we're going to go back to our original inequality symbol and choose our values depending upon what that inequality is. Ours is a less than or equal to. So any numbers less than 0 mean that they are negative. So I'm choosing the table where the interval, choosing in the table where the interval has a negative. So when I graph that, the way that this would look is I have negative 3 filled in because it's less than or equal to, 1/2 filled in, and then in between is where my solutions would lie. Okay, and when we get to the end of this, I'm going to show you graphically what that looks like. Okay, now example 3 is x squared plus 2x minus 5 is greater than or equal to 0. Okay, so there are not two numbers that I can multiply to be 5 and add to get 2. So we're going to use the quadratic formula in here. X equals the opposite of b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is negative 5, all over 2 times 1, which is 2. That gives us negative 2 plus or minus the square root of 4 plus 20, which is 24, all over 2. Now, the square root of, see, now we could simplify the square root, but it's actually not necessary here, okay? Because what we are going to need are what those decimal equivalencies are. So we can figure those out on our calculators. Negative 2 plus the square root of 24, hit equals, and then divide that by a 2. And you get 1.45, say, okay? So 1.45. And then negative 2 minus the square root of 24 equals, and then divide that by 2, and you get negative 3.45. Okay, so again, we don't need to worry about what the simplification of the square root of 24 is when we are simply needing the decimal equivalencies to go on our table. Okay. All right. So our test numbers, anything less than a negative 3.45, a negative 4, in between a 0, and greater than 1.45 would be a 2. Okay. So, because we did not factor this one completely, what we are going to do is plug the test numbers that we've chosen into our quadratic right here. Okay, so if you put a negative 4 in there, negative 4 squared is 16. 2 times negative 4, negative 8, minus 5. So 16 minus 8 is 8 minus 5 is 3, and that is positive. So we'll do the same thing with the 0. If you plug in zeros for all the x's, you get a negative 5. Okay, then we're going to plug a 2 in. 2 squared is 4, plus 2 times 2 is 4, minus 5, which is also a positive 3. Okay, so we are looking for, going back to our inequality symbol, we are looking for the regions in our table that have a plus because of the greater than or equal to. So that's this area here and that area there. Okay, so because this is greater than or equal to, we will fill in those zeros. And let me use a different color just so it shows up better. Okay, we will fill in these zeros and go this way and this way, because those are greater than the areas of the table that are positive. Okay. Now, for example, 4, we're going to use our discriminant. Okay. We have x squared plus x, and we're going to move the 3 over. It's a negative on the right side of the equality, so we're going to move it over and add it. So our discriminant, a is 1, b is 1, and c is 3. So b squared minus 4ab. B squared is 1 minus 4 times 1 times c, which is 3. So 1 minus 12 is a negative number, okay? Negative. So when we try to factor this thing, we're not going to get any solutions that are on the x-axis. Remember, imaginary solutions are those of quadratics that do not go through the x-axis. Therefore, we have no numbers to put on our we have no critical numbers to put on our number line. Therefore, we have no solution. Okay, and I believe that this will finalize chapter 5. Okay. Homework is in IXL.